Hi guys, my name is Tanya Mitchell and I'm an academic mentor and a tutor at TRIO Student Support Services. And the purpose of my video today is to discuss elements and compounds, which is chapter 5 in your Intro Chem textbook. And a few things that we need to talk about for this chapter are the law of constant composition, ratio of masses. We need to be able to identify different types of compounds. So you have molecular compounds and ionic compounds. So we need to be able to identify those compounds as we work through chapter 5. There is going to be a lot of information in this video. I'll try to keep it as short as I can while still covering an ample amount of information for you. The first thing that I want to look at is the law of constant composition. So the law of constant composition states that all samples of a given compound have the same proportions of their constituent elements. Okay, so it's a ratio of masses. So for example, and this may be an example that your professor is using in their PowerPoint slide, but we're going to take a sample of carbon dioxide and we're going to break it down, right? Into the two elements that compose carbon dioxide, carbon and oxygen. And we're going to look at the mass of oxygen versus the mass of carbon to determine the ratio, right? So we have one sample that includes 4.8 grams of oxygen and 1.8 grams of carbon, okay? So if we were to divide this, the answer that we would get is 2.7, right? So this is our ratio, 2.7 grams. For every 1 gram of carbon is equal to 2.7 grams of oxygen, okay? So we'll look at another sample, okay? So we have a second sample, and in that second sample we have 17.1 grams of oxygen, and we have 6.4 grams of carbon. But when we do our calculation, we get the same answer. We get 2.7, right? So this just falls in line with this law of constant composition, okay? So keep that in mind. You're going to have some sample problems asking you to find the ratio of the masses. Simple. Very simple. Okay, so let's take a look at a couple of other things. We're going to take a look at chemical formulas, and we're going to talk about the different parts of a chemical formula, different parts of a compound. Hang out for that. Okay, so what I put on the board here is the chemical formula for water. So let's break it down and look at what is included in this particular formula, right, or this compound. So we have H2O. So our H is our chemical symbol for hydrogen. So as you were working on memorizing those elements from the periodic table, you learned that H is the chemical symbol for hydrogen. And then we have O for oxygen. So that's pretty easy to understand. We have a subscript here of 2. Okay, so what this 2 tells us is that in this compound we have 2 hydrogen atoms, right? There's no subscript on our oxygen. It's just an implied subscript. So what it's telling us is that we only have 1 oxygen atom, okay? So when we have chemical compounds, the number of atoms can change the element itself. So if you look at carbon monoxide, so carbon monoxide is CO. So we have an implied subscript of 1 on each element. But if we add a subscript, it changes the compound altogether. So carbon monoxide becomes carbon dioxide. Okay? So that's why it's important to be able to identify these subscripts and know that when you change a number, your subscript, it changes your compound altogether. Okay? So let's take a look at different kinds of chemical formulas and identify those, define them and identify them. Okay, so we've got two different types of chemical formulas. We have compounds that contain metals and nonmetals, and then we have compounds that contain only nonmetals, okay? So the compounds that contain metals and nonmetals are ionic compounds. And the compounds that contain only nonmetals are molecular. Okay? So one thing to remember is your metals are always listed first. But if you have a molecular compound that includes only nonmetals, how do you know what to list first, right? So that can be a little challenging. But what you're going to do is you're going to list your most metallic elements first. So you might want to memorize this, put it on a flashcard, but you can refer to table 5.1 in your textbook if you have a textbook, and it will give you the order of listing for non-metal elements in the chemical formula. I'll just write them down for you. So the first element would be carbon. Second would be phosphorus, nitrogen, hydrogen, sulfur, iodine, bromine, chlorine, oxygen, and fluorine. Okay? So these are the most metallic to the least or most like metallic elements. So carbon is more metallic than fluorine, so it would appear first in a molecular formula. Okay, so like I said, that's table 5.1 in your textbook. If you don't have it, write it on a flashcard. You will need to know this. Okay, so let's take a look at different types of ions or groups of atoms that work together as a unit and form a charge. So one thing that we didn't talk about in our last video was the different charges of your elements in your periodic table. So we need to look at that, because as you are putting together these compounds, you're going to need to know the charges, okay? So let me just jot that down for you. What you'll want to do is you'll want to write this on your periodic table, and that way as you're working through your homework problems, you can easily refer to this, okay? So your group 1 elements have a +1 charge. Your group 2 have a +2 charge. Your transition metals, like I said, we're going to talk more about those in this chapter, but they can take on a different charge, right? So based on what the element is, it could have a +1 or a +2 charge, a +2 or a +3 charge. So it just depends on what the element is, okay? So then you have your next set of elements here, right? So this is where we start with our metal alloys and our basic metals, right? And these have a +3 charge, okay? Then we have our next listing here. So this is group 3A, and group 4A has a +4 or a -4 charge. So they're similar to our transition metals, as they can take on one or the other. So I would just put +4 or -4 at the top of group 4A. Then we have group 5A, which takes on a -3 charge. Group 6 has a -2. Group 7 has a -1. And then group 8 has a 0 charge. So these are neutral. They do not take on an additional charge. All right, so now that we know this, we can actually start working on putting elements together to form compounds. Let's talk about polyatomic ions. Your professor is going to ask you to memorize a certain group of polyatomic ions. has probably identified those in the PowerPoints, but I will just talk to you about those right now. So, okay, so just to define polyatomic ions, I've written the definition on the board for you, but a polyatomic ion is a group of atoms that act as a unit and have a charge. So they're going to have a plus or a minus charge, right? And so I've put an example of magnesium nitrate on the board for you, and as you can see, it has the chemical symbol Mg for magnesium with an implied subscript. So there's one magnesium atom in this polyatomic ion. And then we have the chemical symbol for nitrate. This looks a little bit different because we have parentheses outside of this, right? So inside the parentheses we have nitrogen and oxygen, and we have a subscript of 3, which indicates there are 3 oxygen atoms in this particular compound. Outside the parentheses we have a 2, okay? So this 2 subscript indicates that there are 2 nitrate groups for this one magnesium. And when we break this down and start building chemical compounds, this will make more sense to you, but I wanted to identify it for you early in this video so that you have an idea of what it is that we're looking at, okay? So let's take a look at the list of polyatomic ions that your professors are going to expect you to memorize. They are not listed in your book in any particular table. There is table 5.3, which shows you some of the more common polyatomic ions. You will need to flag that because as you are doing homework and studying for exams, you're going to need to know what these are when you put them together. Now, if you're using the 6th edition Intro Chem textbook, that table 5.3 is going to be on page 143, okay? So we're going to take a look at those polyatomic ions that you're expected to memorize, and you will need to be familiar with these by the end of this chapter because you're going to be using them for the remainder of the semester, okay? Okay, I have listed the polyatomic ions that you need to memorize, so you want to put these on a flashcard. One thing that I want you to pay careful attention to, a lot of these may look like the same thing, but if you look very closely, you have nitrate and nitrite, sulfate, sulfite, then you have phosphate or hypochlorite, then you have chlorite, chlorate, perchlorate. So these are all chlorine-based compounds, and it can be very confusing. One way that I found made it easier to memorize these is to look at the number of oxygen that are in the compound. So you know that if it's an ATE compound, like nitrate, it has more oxygen than an ITE, right? So your nitrate is NO3, where your nitrite is NO2. And for your perchlorate, per means 4. So that means that there are 4 oxygens, right? Hence ClO4, okay? So that's just one way that I used, one method that I used to memorize these polyatomic ions, and I wanted to show you those. So you have your chlorate and your chlorite. So your chlorite has only 2 oxygens, where your chlorate has 3. But then you have your perchlorate, which has 4, right? So put these on a flashcard, whatever you need to do to commit them to memory, because you will be tested on those. They're probably going to be on your Chapter 5 quiz, so get started on it now. And then let's take a look at being able to identify the number of atoms in a compound. And it's just a real short exercise, so we won't spend too much time on it, but it is something that you're going to be expected to know. So we'll take a look at that next. So this exercise is going to be very quick, but I wanted to show you how to identify the number of atoms in a compound. So we're going to take magnesium nitrate here, just as an example, and we're going to break it down and determine how many atoms of each element are in this particular polyatomic ion. Okay, so we have our magnesium, and then we have nitrogen and oxygen, right? So we can look here, we have an implied subscript of 1 on our magnesium. So we have 1 magnesium atom, okay? Then we look at our nitrogen, okay? So nitrogen is just a part of the compound nitrate. This is in parentheses. So what that means is this subscript right here goes with every element inside the parentheses, right? So you have an implied subscript of 1 on this nitrogen. So 2 times 1 is 2. Okay? Same thing with the oxygen. So this subscript goes, like I said, with everything in the parentheses. So you might look at this and think, oh, well, I've got 3 oxygens. Well, you don't. You have 6, because you're going to multiply the 2 times the 3, and it's going to give you 6 oxygen atoms. This is very important, guys, as we start, as we move forward, and we're going to be balancing chemical equations, and we need to be able to readily identify the number of atoms in each compound. Okay, so this is just an exercise just to show you an example on how to do this. I'm going to put a couple of these on the board that I would like for you to work independently. So you can pause the video, whatever, come back to it later, write it down, put it in your notes, whatever you need to do, but you need to practice this, okay? So let's take a look at here's a compound for you. Oh, wrong. So there's one.
The applications that we have over there, do you want me to go through, or?
Yes.
Okay. I think we have about 10.
Okay.
So I'll go through and I'll print forms.
PO4.
And then also,
And
that first
Li2.
generation college student day,
SO4.
want to schedule for November.
Okay,
9th.
so these are just 3 compounds I'd like for you to jot down and work through them and determine the number of atoms in each compound. Okay, should be pretty easy based on the example I just gave you, but like I said, it's something that you have to be able to do. You must be able to do this. Okay, so we'll go ahead and pause the video, and when we come back, I will have the answers written on the board for you. Okay, so just a quick review. We have 3 compounds on the board here, and I've broken down the number of molecules or atoms per compound. So for your first compound here, we've got 1 molecule or 1 atom of calcium, 2 chlorine, 8 oxygen. For our second compound, we have 3 nitrogen, 12 hydrogen, 1 phosphorus, and 4 oxygen. For the final lithium sulfate, we have 2 lithium, 1 sulfur, 4 oxygen. Okay, so that's just a quick review on how to identify the number of atoms or molecules in a compound. Like I said, you'll need to know this for your quiz, your exam. So your Unit 2 exam is where a lot of this is going to be covered. The thing that I want to talk about now is types of chemical formulas. So we're going to take a look at that now. I have identified 3 types of chemical formulas on the board for you. So the one that we use most often are molecular formulas. So an example of that would be H2O2, which is hydrogen peroxide. And so a molecular formula represents the actual number of elements of each actual number of atoms of each element in a compound. Okay, so molecular formula. An empirical formula is kind of like a skeleton, so it's the simplest whole number ratio of atoms of each element in a chemical compound. Okay, so you have your molecular formula for hydrogen peroxide is H2O2. The empirical formula is HO. And then we have our structural formula. This is something that we will get into in more detail in lab, but this is a compound, this is CH4, and so this would be the structural formula for CH4. And we're not going to go into too much detail on this, I just wanted to show you what it looked like. So just a quick recap of what we've covered so far in this video. We've talked about molecular compounds, we've talked about ionic compounds, we've talked about polyatomic ions, we've talked about how to identify the number of atoms or molecules in a compound. What we're going to get into now is writing formulas for compounds, okay? So what I've done is I've identified a couple of key points here. In molecular compounds, which are two nonmetals, your elements share electrons, okay? In ionic compounds, the metal, which is your cation, donates electrons to your anion. And they do this so that they can form a neutral compound, a neutral charge on the compound, okay? So wanted to review that real quick. One other thing, I'll go ahead and put this on the board. Like I covered previously in talking about the different charges on your periodic table, you need to know what the charge is for each group, okay? So you have group 1A, and that has a +1 charge. So your group 2A is a +2. Your group 3A is a +3. So 4A can take on a +4 or a -4 charge. So your 5A is a -3. Your 6A is a -2. 7A is a -1. And your 8A elements, which are your noble gases, have 0 charge, okay? You absolutely have to know this before you can successfully combine elements to create a compound, okay? So, write that down, put it on your periodic table. Whatever you need to do in order to remember this, you need to do it now. All right. So let's take a look at writing formulas for ionic compounds. So we're going to write an ionic compound for these two elements. So we have iron with a +2 charge, and we have bromine. And bromine is located in group 7A, so it has a -1 charge. All right, so the first step to writing an ionic compound is to take these two elements and put them together. So these two look like this. And you may be saying, well, what do I do with these charges? Okay. So what we do with our charges, in order to create a neutral compound, the bromine takes on the charge of the iron, right? So this 2 comes here, and this becomes a 2 subscript. So for every 1 iron, there are 2 bromines, okay? This -1 charge becomes an implied subscript for your iron, okay? But we don't write a 1. That's just redundant. So this is an implied subscript of 1. So our correct compound, ionic compound, for a mixture of iron and bromine is FeBr2. Okay? So let's apply this concept to something else. Let's look at another compound. So let's look at sodium and iodide. So we have sodium, which has a +1 charge, And let's look at iodine, which has a -1 charge. Okay? So our subscripts will each be 1. They'll be implied subscripts, so we won't put anything when we combine these two together, right? To form sodium iodide. Okay? Easy breezy. Let's take a look at calcium and hydroxide. So we have calcium, which is a 2+ charge, and we have our hydroxide, which is a -1 charge. And you don't have to put the 1 here, you can just leave it with a negative mark so you know that this is your anion and this is your cation. When you bring these two together, what happens with these charges? Crisscross applesauce, right? So you take this 2 and it comes down here. Okay, so the reason I wanted to show you this is because this is a polyatomic ion, right? So when you add your subscript to your polyatomic ion, it has to be put into parentheses, all right? So it's going to take 2 hydroxide ions to balance the calcium, right? Because this is a -1 charge, it has an implied subscript of 1. Our hydroxide takes on the 2+ charge, so there's 2 hydroxide atoms or ions to 1 calcium ion or atom to balance this out and make this a neutral compound. Okay, so let's put a few more of these on the board that you can work independently just as practice before your chapter 5 quiz, because this will be included. Depending on who your professor is, you may have several, you may only have a few, but you still need to know how to do it. So for most of you, these elements or these practice problems are listed as part of your homework that your professor gives you for each chapter. So we won't take the time to work these out and identify or put them together because we need to spend some time naming the compounds, knowing how to name them, learning the rules for naming compounds. I just wanted to put these on the board so that you can work them independently and get more practice. Okay, so go ahead and write these down and work on them. If you need to pause the video and then come back to our next topic, or you just want to write them down so you can work them out later. But you definitely want to get the practice on these because, like I said, you're going to see them for the remainder of the semester. You're going to be quizzed on these, you're going to have them on exams. They're not going away, guys, so you need to learn how to do it now. All right, so let's take a look. Our next topic is going to be naming elements. Okay, so I have potassium fluoride on the board here. And so we need to give this compound a name. So we know that our K stands for our potassium. And the F is our fluoride, fluorine. F-L-U-O-R-I-N-E. When they combine, they create potassium fluoride. So INE changes to IDE to create or to give it the name of potassium fluoride. Okay, and this rule applies to ionic compounds. Molecular compounds are the same with a few exceptions. So let's take a look at a couple other ones. We've got barium and oxygen, and when they combine they form barium oxide. If you put barium oxygen, you'll get it wrong. It's barium oxide. Let's take a look at rubidium, and iodine. Rubidium stays the same. And we have iodide, IDE, okay? So we'll put you've got a few of these in your homework. I heavily suggest that you do them because the rules are going to change depending on what kind of compound it is that you are being asked to name. Okay, so let's take a look at a polyatomic ion. So we have a polyatomic, this one here. Oops. Yeah, CO3. Okay, so we know that Na is sodium. And we know that this is carbonate, right? This is a polyatomic ion. So this doesn't become carbonide. It stays carbonate. Okay, so this is sodium carbonate. So when you combine a cation with a polyatomic ion, the IDE rule does not apply. Okay? Does not apply. We'll look at another polyatomic combination. So we have magnesium and chlorate, ClO3, 2. So this is magnesium chlorate. Yeah. So once again, this does not become IDE because it is a polyatomic ion, so it stays ATE, chlorate, magnesium chlorate. So there's several of these in your homework. I suggest that you go ahead and work on them. What I'd like to go ahead and talk to you about now is naming the molecular compounds, because they have several rules that go with them and some prefixes that you have to memorize in order to be able to name them. So let's take a look at that next. Okay, so these are the prefixes that you have to know when naming molecular compounds. So the first step in naming a molecular compound is identifying it as one. So nearly all molecular compounds form between two or more nonmetals, right? And so binary or two element compounds, molecular compounds, take on the form, you have your prefix, then the name of the first element, and then you have another prefix, and then the name of your second element. Right? So let's take, just for example, let's take a look at CO2, right? CO2. So in naming this, we have one carbon atom and two oxygen atoms. So our prefix for 2 is di, right? Our prefix for 1 is mono, but since our first element, it has only one atom, it's implied. we don't have to put mono in front of our first element here. So this would not be mono carbon dioxide, right? If you put that on a test, that'd be wrong. You do not use mono with the first element. You use it with the second element, third element, etc. So the correct name for this element is carbon dioxide. So if your professor were to give you this in word format, carbon dioxide, you would know that it is CO2. Okay? But if your professor gave you in word format carbon tetrachloride, you would break this down and you would know that you've got one carbon atom and you've got 4 chlorine atoms. Tetra is 4. So your formula or your compound would be CCl4. Okay? So let's take a look at a couple more and then we'll move on. So now we have BCl3, right? So we have boron, and we have 3, and the prefix for 3 is tri, so it's boron trichloride. Now, when you're writing these chemical compounds, the second element does not have to be capitalized, right? So boron trichloride. Let's look at another one. SF6. So this is going to be sulfur. And the prefix for 6 is what? Hexa. Fluoride. So sulfur hexafluoride. Okay? So with this concept or with this skill, you should be able to name any element that your professor throws at you. And we're going to take a look at acids. So acids are a challenge. You definitely want to get a good understanding of naming acids because you will be naming a lot as you move forward in this class. If you go on to an intro to organic and biochem, you're going to need to know this stuff. So for you dental hygiene students, any students that are planning to go into the MLT program, you have to take intro to organic and biochem. And so without this knowledge, without these skills, you will not be successful. And I'm not telling you this to try to make you upset. I'm just being realistic. You've got to get an understanding of this now moving forward in order to be successful. I mean, everybody wants an A in chemistry, intro chem. For some people it's not realistic. For some people a B or a C is the best they're going to get. But it won't be because they didn't try. Okay? So as long as you try and you put to use the skills that I have shown you, then you will be successful. I know that you will. All right, so let's take a look at acids next. Okay, so when it comes to acids, there are 2 types of acids, and an acid is a molecular compound that forms ions when it is dissolved in water. Okay, so it's aqueous. Aqueous, you'll see this as you're writing chemical formulas, is AQ. So that means dissolved in water. Okay, so acids, you'll be able to identify an acid in looking at a chemical formula when it has an AQ after it. Okay, aqueous. So there are 2 types of acids. There are binary acids, which contain only hydrogen and a nonmetal. And then we have oxyacids. So oxyacids contain hydrogen, a nonmetal, and an oxygen. Almost always will they have a polyatomic ion. We'll talk more about oxyacids in just a moment, but I wanted to talk more about binary acids. So binary acids, when you're naming binary acids, I know that one of the rules we had for molecular compounds is that you had to use prefixes, right? So with binary acids, we do not use prefixes. Ever, ever, ever. We don't use prefixes. So when we have two elements, so we have HCl, so this is hydrogen and this is chlorine. So this becomes hydrochloric acid, right? So your IDE becomes an IC, hydrochloric acid. Same thing with hydrogen and bromine. So this becomes hydrobromic acid. So with binary acids, we lose our IDE and it becomes an IC. Okay? So the rules for naming binary acids, our first name is hydro, and this represents our hydrogen, plus we have the base name of our nonmetal, but we add an IC, right? IC, and then the last name is going to be acid. So if you just think of it as first, middle, and last name, it'll be easy to remember, okay? So let's take a look at a couple more. I'll put a couple more up here, and you can just work on those independently because you're going to see a lot of these for this chapter, binary and oxyacids. So we'll just put two more up here on the board that you can work by yourself, and then we'll take a look at oxyacids. So if you have, this is an I and H2S. And remember what I said, no prefixes in binary acids. So work these independently, and when we come back together, we're going to work with oxyacids and naming oxyacids. Okay, so oxyacids are a little bit different. We talked about the different polyatomic ions that end in ITE and ATE. So the two rules that we have in regards to those is if you have an oxyanion that ends in ITE, then the acid name is going to be the base name of your oxyacid plus OUS. Okay, that's for ITE. So for ATE, if your oxyanion ends in ATE, then the base name of the oxyanion plus IC acid. So an example here would be HClO3, right? This is going to be chloric acid because this is chlorate. And so following this rule here, we take the base name of our oxyanion and we add IC and it becomes chloric acid. So for this oxyanion, we don't identify the hydrogen, right? Like we do in the binary acids with some of those compounds. With an oxyanion, hydrogen is part of the compound, but it's not part of the name, okay? So it's important that I point that out. So your professor has listed several acids that she wants you to name. So this is a good time to practice on that. This is just an example of one of the problems that's on your homework set. So just remember these rules. If you need to put this on a flashcard, you need to memorize it. So ITE is OUS. ATE is IC, okay? And then for the last thing that we're going to talk about today is formula mass. So grab your periodic table and your calculator. When we come back together, we're going to do formula mass. Formula mass. So you may hear it called formula mass, atomic weight. There are several different ways to call this the same thing. Formula mass. So formula mass is the sum of the atomic masses of all the atoms in a chemical formula. Okay? So the formula for formula mass looks like this. You have the number of atoms of your first element times the atomic mass of the first element plus the number of atoms of your second element times your atomic mass of your second element. So just as an example, let's take a look at the formula mass of water. Okay? So water, we know, is H2O, right? So if we want to find the formula mass, we're going to take 2, which is the number of molecules, times the atomic weight of hydrogen, which is 1.01. And then we're going to add it to the number of atoms of oxygen, which for this case we have 1, times the atomic mass of oxygen, which is 16. Okay? Alright, so we can put this into our calculator, do it in our head, however you want to do it. So this is going to be equal to, so 2 times 1.01 is 2.02 plus 16 equals 1802. And the unit for atomic mass is AMU. And you always need to identify your element. So always include your units, always identify your element. Okay? So that is how you calculate the formula mass. So let's do another one. Let's do another example, or a couple more examples, and then that'll be it for this video. Okay, so we're going to calculate the formula mass of carbon tetrachloride. And so based on the formula that I just presented to you, we're going to take our formula mass is equal to 1 molecule of carbon times the atomic weight of carbon, which is 12.01. And we're going to add that to the sum of 4 molecules of chlorine times the molecular weight of chlorine, which is 35.45. So that's going to give us 12.01 plus 141.80. So the total formula mass, atomic weight, whatever term you want to use for this, we're using formula mass. So the total formula mass for carbon tetrachloride is going to be 153.81 AMU. Okay? Don't let the number of molecules throw you off. So it's always the number of molecules times the atomic weight to get the AMU. All right? So let's take a look at dinitrogen monoxide. So for this one, we're going to calculate the formula mass. So we have 2 molecules of nitrogen times the atomic weight of nitrogen, which is 1401, plus 1 molecule of oxygen times the atomic weight of oxygen. So 2 times 1401 is 2802. We're going to add that to 16. And so that's going to give us a total of 44.02 AMU. Okay? Alright, so formula mass is not that hard. Naming the compounds is not that hard. Just takes practice. This is going to be it for this video. So this is chapter 5. Atoms or elements and compounds. Our next chapter is where we get into some more complex concepts. So we're going to be working with chemical formulas, finding mass percent. We're really going to be applying everything that we have learned up until now in chapter 6. So chapter 6 is chemical composition. So look for that video. It will be helpful as you're preparing for your Unit 2 exam and as you are covering different concepts in lab. So lab is pretty fun. Everything that we learn in lecture applies to lab, so keep that in mind. Once again, if you guys need anything, reach out. I'm in the TRIO office on Monday, Wednesday, and Friday. And I'm in class on Tuesdays and Thursdays. I do respond to email, so you can always email me at tmitchell@rose.edu. If you need to schedule an appointment, a tutoring appointment, and you are a TRIO student, give us a call at 733-7379. If you're not a TRIO student and you want to learn more about TRIO and how you become a part of the TRIO program, go to our link tree, and it's linktr.ee/RSC TRIO. So this link tree will give you information about TRIO, what the program is, what it does, and how to become a part of it. It'll have our online application. It'll have an online link for our YouTube videos, Facebook, Instagram. It also gives you an online link for the tutor request form. So if you're not a part of TRIO and you want to be a part of TRIO, Linktree is where you need to start. And that way we can get you started on the application process, get your intake interview scheduled. We'd love to have you become a part of our program. So like I said, that's it for this video. I appreciate you watching and continuing to watch. Subscribe to our YouTube channel, the Rose State TRIO YouTube channel, and every time a new video is posted, you will receive an alert. As always, take care of yourself, stay safe, stay healthy, and I'll see you next time.